Hi, this is Mark Zarazana from the International Piano Technician School. I just want to share with you the stretch interval set that we use in order to help us make the maximum number of pure intervals. Now this is shown something like this, which can be a really confusing mess of figures, numbers, colors, letters. So I just want to start at the beginning with a piano keyboard down here at the bottom, and we'll just throw in two notes. This is just the A sharp 3, A sharp 4 octave. Now if we want to check that octave for its 6/3 size, for example, we throw in this check note right here, the C sharp 4. The coincident partial happens up here at F6. What I like to do is show these notes at heights that allow us to see the size of the intervals. So in this case here, we've got the A sharp 3, C sharp 4 coming down like this. That shows that it's a narrow interval. And then the C sharp 4, A sharp 4, the major 6, that's showing coming up like this. It's a wide interval, and that's exactly what it is. The minor thirds are narrow, the major sixths are wide. And because the A sharp 3, A sharp 4 is right beside each other, side by side, that means it's pure. So in this case, we have the minor third equaling the major 6, producing a pure 6/3. We can show these intervals here in these circles. Now, we can see here that the minor third is not as steep, so it's slower, getting closer to pure where they're side by side. So this is a slow minor third, and the 6 is steeper, so it's faster. That's a wide 6/3. This is a narrow 6/3. If these are the same speed, minor third, major 6, if they're the same speed, we have a pure 6/3. And that's how this diagram shows these intervals. Now, the square is the interval that's being checked by the major 6 and the minor third, and if they're joined together with the lines, it means they're equal. And then that interval in the square box is pure. Let's look at some other intervals. Like let's throw in this note here, the major 17th. If we look at the major 17th with the minor third or the major 6, for example, the major 6, we produce a 12th, an octave and a fifth, which has, by the way, the coincident partial also on F6. Very interesting. Now, if this major 17th is tuned too slow, the F6 is tuned too low, producing a slow major 17th, we got a narrow 12th. If it's tuned too fast, faster than the 6th, we got a wide 12th. But if it's tuned the same speed as the major 6, we've got a pure 12th. Now, at the other note that we were just talking about, the A sharp 3, we get a 19th, which, by the way, also has a coincident partial at F6. Again, if that 17th is too low, the 19th is narrow. If the F6 is too high and the major 17th is too fast, we got a wide 19th. So if it's the same speed as the minor third, we have a pure 19th. So that's the beginnings of the stretch interval set triangle. Let's look at some other notes. Throwing in this note here, the minor 6, we can choose any one of these notes to analyze. Well, let's choose this top note. That would make it a triple octave, which has coincident partial, coincidentally, at the F6 again. And again, if its 17th is too fast, if the F6 is too high, we have a wide triple octave. If the F6 is too low, the 17th is too slow, we have a narrow triple octave. So we tune it the same speed as a minor 6, so we have a pure triple octave, pure 22nd. The other intervals here that we can look at are, for example, the 11th, the octave, and the 4th, F3, A sharp 4. By the way, it also has a coincident partial at F6. If the beat speeds are the same, we have a pure 11th. And the only other interval here we have to look at is the one produced by the minor third and the minor 6. That is the perfect 4th at the 8/6 coincident partial, again, F6. All of these intervals have the coincident partial at F6, which makes it really simple to understand and to know what the coincident partials are. So when the minor 6 and the major 6 are the same speed, we have a pure 4th at the second coincident partial. So these are all the intervals in the interval stretch set that produce pure intervals in the fast beating set. But there's also two notes that we use to produce the slow beating set. Let's look at those. Again, using the check note of C sharp 4, it's this octave here, F4, F5. When we use that check note, C sharp 4, we're testing the 4/2, the coincident partial at F6. The interesting thing is if we throw in one of those other notes from the previous set of blue notes, for example, the major 6, we see something very interesting. Like I said, the yellow notes will be tuned slow relative to the blue notes, which are faster. So here we have a slow major third and a fast major 6. That proves that the 4th, F4, A sharp 4, is wide. We got a wide 4th. If you look at these two notes here, we have a major 6 and a major 10th. So if the major 6 is faster than the major 10th, we prove that we have a narrow 5th. So throwing in these extra notes allow us to prove that we have a pure 4/2 with a wide 4th and a narrow 5th. And when we throw them all together, here are all the notes. We tune the major third, the major 10th, slower than the other intervals, from the left to the right, the minor 6th, minor third, major 6th, major 17th, we get this. So everything we just talked about is in this diagram. At first blush, it may look very complicated, but if you go through and watch the video again, you'll see everything we talked about is in here. And that is the International Piano Technicians School Mark Ceresano tuning system way of tuning pure intervals in the treble and in the bass. It's not always possible, but vast majority of the time we can do this. And there's other reasons why we can do it that have to do with auditory illusion and things like that. But this is a very clear way of tuning the stretch without guessing. And this is why I love it, and it's helping students get really good results. So I hope that explains the stretch interval set for maximum pure intervals. Thanks for watching.